Hey guys, thank you guys for bearing with me as I'm trying to figure out the whole distance learning thing along with you guys. And it looks like a lot of people really struggled yesterday with the graphic organizers and with going through the textbook and pulling out some of that information. So I'm sorry if you were like super frustrated. Submit whatever you have if you haven't already. And I will spend some time over the weekend kind of ironing that out and getting you some resources. So I've changed up what I had planned for today. And so rather than do the lecture, I think it may be useful to get a little bit more hands-on and be able to visualize some of the things that we're talking about. And that'll hopefully support us for next week when I do go a little bit more into the lecture piece. So the game plan for today is the Gizmo. There's actually going to be two of them, and hopefully you're able to go through at a pretty decent clip there. Then I'd also like over the course of today to be able to get up your assignments for Monday. That way, if you want to go in and get a little bit of a head start, you can do that. And you can, especially for those of you that know you need a little bit more time to digest information, you can do that. Now, one word of, kind of insight here is you're not going to have tests on this. You're not going to have a formal test. So I know for some of you, you're planning on taking AP or anatomy and physiology next year. I would highly recommend still investing that time to make sure you're understanding these concepts. But if you are just trying to get through this and you've got a lot going on, I completely understand. Still try to understand the information, but please don't stress, okay? So you'll have a couple of gizmos today. And then on Monday, I'm going to put up, oh, that's a little out of size. There we go. A couple of quizzes. The hope being that you can kind of self-assess, see what you know, see what you don't. I'll also put up lectures that go back to the 3 homeostatic mechanisms, the oxygen, glucose, and water regulation, and those feedback loops for those. So I'll do 3 separate videos so that you can watch what you need. But again, this is really to make sure that you're understanding it, and there's not going to be a formal assignment with the lectures other than to do the quizzes. On Tuesday, you'll have a little bit of a worksheet that goes over passive transport and introduces some of the active transport. Wednesday, I'll go ahead and wrap up with everything you need to know for active transport, because your test is going to be the unit 4 summary activity, or the unit 4 assessment. And so you are going to have time on Thursday and Friday. Rather than give you a regular assignment, I'm going to give you that time to work on the 65-point assignment there. Now, as you're going through everything, if you're finding that most of this is really easy, you're understanding it, you should find that that assessment is something that really does only take you about 2 hours. If you have not been understanding this whole time, then it's going to take you a lot longer than that. So I'd really recommend you investing some of the time to make sure that you are watching the lecture videos if you need it, asking questions if you need it, etc. So without further ado, I'm going to give you a quick overview of what today is going to look like in terms of the gizmo, and then you can be free to go. If you feel like you can do it on your own, that's fine, and I'll stick around and then do a little bit more of a tutorial on the gizmo so that you're more comfortable with that. So without further ado, let's kind of put that out to the side. Okay. So here's your worksheet. You'll want to download this, again, preferably as a Pages document. It's going to make it a little bit easier for you to edit and a heck of a lot easier for me to grade, because I have been finding that people that are submitting these, if you've been doing them on preview as a PDF and just doing the little thing that says insert text, that is getting really wonky on my end. So if you can do it on Pages, great. If you still have to use the PDF viewer, that's fine. I can make it work. So what you're going to be doing is starting out answering these 3 questions. I don't need anything super sciencey. I just want you to make sure that you're solid with understanding the terms permeable, concentration, concentration gradient, solvent, solute, etc. At that point, you're going to log into your Explore Learning account. And if you didn't already set one up, go back and watch the video and read the Schoology assignment from last week at some point where we did the first gizmo. The code is right there for you, okay? So with the diffusion gizmo, what you're going to be really trying to pull out, okay, so it kind of looks like this when you set it up. The idea here is that we've got this wall, and this represents how permeable something is. So if it's completely not permeable to a particular solute, then it's kind of like a wall is there. Nothing can get through. Now, this is not selectively permeable. It's going to let everything that can get through. But as you go lower and lower, it represents an increased permeability. And so we're just going to set up the different solutes, the amount of X that's on side A, the amount of Y on side B, change those around, change the temperatures, etc. And so in part 1, you're just looking at molecular movement, answering questions. And 2, you're going to modify the temperature and see how that affects how long it takes for equilibrium to be reached. In part 3, you're going to do something very similar, and it's just that you're changing what the concentration gradients are to start. And then when you're done all of that, you'll go to the second gizmo, which is, oops, that's not what I wanted at all. And you will have it already up in your class. There we go. And it's going to look like this. And the idea with this, I don't need you to know what all of the different parts of the circulatory are called, of the circulatory system are called. You don't need to worry about, there we go. You don't need to worry about knowing the parts of the heart, but this diagram is just a representation of what's going on in your body in terms of blood flow. And so you'll turn on the blood flow, you'll turn on the labels, and you can kind of see where the blood is going and then returning back to the heart. So it's going out of the heart to the lungs, and then back to the heart, out of the heart to the rest of the body, back to the heart. And so what you're going to be looking up is how much of each of these solutes, how much oxygen, CO2, urea, and blood sugar there are in the different parts. So for example, in the lung, you'll just take the syringe from the heart into the lungs. It's going to start here. So into the lungs is this way. You're going to take this data and plop it on in, analyze it, and answer your questions. So without further ado, if you feel like you're ready to go, by all means, the video is over. If you feel like it would be helpful for you to watch and me kind of guide you through some of it, I will do that now. If I don't see you, I know I won't see you, but if you're all done, I hope you have a good Easter. Anyway, moving on. All right, so let's go back to the diffusion gizmo. It says set your simulation right here as follows. So we're going to set it up so that the wall is all the way down, that the amount of X in A, so that just means the purple particles. You'll see that if I bump this up, there's green particles too. We're just going to look at the purple ones. So we want that to be all the way, bloop, all the way up. We want our temperature all the way down and our particle mass all the way up. This is going to cause the slowest movement. And why do we want that? Because what you guys are going to be doing, you are going to make your concentration comparison, right? Obviously, you can see A and B are different, but you're just going to try to watch one particle as it's going on for 90 seconds. 90 seconds doesn't mean 90 real seconds, it means 90 seconds in the gizmo. So for example, I'm going to try to follow one with my mouse. I don't know if I'll really be able to do it, but you'll hit play and you'll just pick one at random. Oops. And try to follow what this guy is doing. And you'll notice that they bounce off of each other a lot, but that's okay. All right, right, like 60, 70 seconds. All right, he's just bouncing around a little. Refresh it, start it again, pick somewhere that, a guy that started somewhere different. Oh, he started moving fast. This one. And just kind of observe what's happening. You're gonna do that 3 times, okay? Refresh it, and then you're going to then, it says this time do not focus on a single particle, just kind of note what's going on overall. So we're going to do this the fourth time, but this time we're just looking at the big picture. We're not trying to focus on just one little particle. We're seeing all of it together. So when you hit play, watch it for about 90 seconds. And so this is going to give you a better idea of what the individual particles are doing versus what they're doing overall. Okay. All right. In the second part, we're going to hit reset again. You're going to set this up now with your permeability or your wall at 50%. We're completely filled with A. There's no B. Don't worry about temperature yet. And we're going to bring this all the way down to a particle mass of 1. Okay. Did I want it? Yeah. Yes, I did want it like that. Good. Just double checking that I didn't mess something up. And then you'll see that it says open the tab that says table. So that's this guy right here. So we're going to be watching this and seeing when our amount of X inside of side A drops to below 55%. That's going to indicate that we've roughly reached equilibrium. Not completely. You never stay at like exactly 50-50 on two sides of the membrane or exactly, equal, but it's relative. So 55%-ish, and we're in good shape. We're going to take our temperature and do what it says, which is to bump it to 275 Kelvin. Notice it's not degrees, it's just Kelvin because of the way it is. And then blah, 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 blah. We're going to hit play. It's going to do its thing, and we're just going to watch it until it hits 55% in this column right here. And what's really great is the table is set up so that the timing is also right there. We don't have to worry about trying to hit pause exactly when it hits 55. Okay, so I can see that for me, 102 seconds, it hit it. I would put that into this place right here, right? 275. That's not right. 105. That's what I said. You're going to just repeat the experiment 2 more times and then find the average. Now bump it up to 375. Oops, you have to hit refresh each time. Bump it to 375. Rinse, repeat. You'll then make a comparison about how long it takes for you to reach equilibrium in both of those states, in the warmer and the cooler temperature, and then you're going to look at the importance as it relates to human thermoregulation or temperature regulation. Lastly, setting your simulation still at 50% there. There's no Y. We're bumping this all the way up, maxing out how fast everything moves. Open the tab that says bar chart, and what we're going to be looking for is the point at which the amount of X inside B gets up to 20. Okay, so we'll set this to 50 to start. Right, so set the amount of X in B, hit play, continue the simulation until the amount of X in B is reaching 20. And oops, I forgot to do that. So we're just going to hit play, go until it hits 20, record, do it again, record, do it again, record, and then we're going to bump this up, reset, bring that X and A all the way up to 100, see what happens there, relate it back to the human body, and boom, ready to move on. For the circulatory gizmo, let's refresh this so you can see what it's going to look like when you first start it up. So right now you can't really tell what's what, so we're going to turn the labels on. So here's our heart. It's got kind of a 2-pump system, 1 pump on your right side, what's being shown as the left side here. So your right atrium and right ventricle pump out blood to the lungs. From the lungs, they're going to then, that blood's going to return to the heart and go on to the left side of the heart and then flow out to the rest of the body. Now, as I mentioned, this is clearly not what humans look like, right? Our arms are way longer, and we're going to have capillary beds that break apart all along our arms, all along our legs, all in our heads. It's not like one artery comes up and then just one capillary network. There's like a bunch of little arterioles and so forth, but this schematic does a good job of at least showing you the general scheme, the general flow of blood. And when we turn on the blood flow, we can see it, okay? Blood returning from the lungs to the heart, coming in and getting pumped out to every part of the body. From there, it's going in the arteries into the tiny capillaries. The capillaries are where the exchange of materials are going to happen, and then that blood returns back up to the heart. So why does this matter? That exchange of material is what we're going to try to understand a little bit better. So we're going to take our syringe and see what's happening in the various areas. For example, if I take my syringe and I put it right here in the lung. So let me actually put this, yeah, let's wait till the blood comes back. Okay, so the blood's in here. So when it first comes to the lung, it's coming in through this artery right here. So I'm gonna bloop, get some data from that. These data right here are what I would then write in here. So 35.4, 48. Okay, and then, come on. That's going out to the rest of the body, coming back. So the blood goes to the heart, out this way to the lungs, and then out of the lungs. So right here is where I would want to take it for that in out, right? So it came in the lungs via this artery and it's returning via this vein. You'll have to kind of watch where the blood flows. In any case, I take my sample there and I find that I'm at 93.1 millimeters of mercury, of oxygen. I've got my other data. Anyway, you're going to continue this and you'll find that your data are going to be a little bit different than my data, and that's fine. As you're going through, don't worry about left versus right. If it's anything that's paired, just pick one, run with it, and you're fine. From that, you're then comparing. Where do you see the biggest increases, decreases, or what areas maybe didn't have so much of a change for oxygen, CO2, sugars, and urea? Based on what you're going to find, and I'll tell you, what's going on in most of the body is going to be one thing, but then you're going to notice that, for example, oxygen, the only place that it's increasing, hint, hint, is going to be the lungs. The only place that carbon dioxide is decreasing is going to be the lungs. So you can use that information to start drawing conclusions. So it says, using the data from question 11, make claims about each of the different body parts and what their role is in the body in terms of maintaining homeostasis. So if you've got questions, let me know. I hope this little tutorial made it a little bit easier for you as you're going through. And have a great, nice long weekend. I'm sure it's going to be just as boring as the last 3 weeks have been. But all right, take care. I'll see you on Monday.